mentioned, this is our last set of notes for 2023. This is our last set of notes for Unit 5. We've been talking about factoring, lots of different types of factoring. And so the last one we're going to talk about today is factor by grouping. And then we're going to do some multi-step factoring practice on the back. That's not really notes. It's really just some more practice that we'll go through together. When you have some more complex expressions and you have to use more than one method or more than one factoring style. So the grouping method, these steps should look familiar because we actually previewed grouping when we were doing our trinomials with a greater than 1 on Friday of last week. So let me pull up and refresh your memory. So remember, we said if you have an a value greater than 1, we can start with this x method, where we put a times c in the top, b in the bottom. We look for what multiplies to ac but adds to b, and then we make the substitution. We replace that middle term of the trinomial with these two terms, and it creates 4-term expression. Y'all recall this? Okay. So we were going from a trinomial and we were making it 4 terms instead of 3, because then we had the option to do either box method or grouping. Okay, so what we're going to look at today is very similar, except we are starting with 4-term expressions. So we get to skip the whole X method part of it and jump straight to the grouping. Okay, so these are starting with 4 terms already. Okay, now if there is a GCF, we do want to take out that GCF first. So you can see in this example that's shown, there's a GCF of 2. All of those are even numbers. We can divide out that 2. Okay, we still have 4 terms left, and they do the grouping process. Remember, you create your 2 groups. You do the GCF of each group, and then we know that the leftovers, when you do the GCF of each group, those leftovers should come out the same, right? That's what it says right here. Those remaining binomials should match. Okay, and then that, if that matches, that means that is one of your factors. And then your other factor is the GCFs that you pulled out. Those come together to create the other binomial factor. Now, in this case, we had a GCF that we took out at the beginning. It does not disappear. Notice it's still here in front of both of those binomials. Okay, so first factor out a GCF if possible. Okay, and then you do your grouping method. Now, if you have factored correctly and your leftovers do not match, that tells us that it's a prime expression. It's not factorable. Good? All right, so let's jump into some examples here then. All right, in A, first I'm going to ask myself, is there a GCF? Because remember, step 1, first factor out a GCF. Okay. Is there a GCF in A? No, I don't see a GCF. Okay, so no GCF, so I'm going to just jump into making my 2 groups. So my groups, the first 2 and the second 2 terms. So in my first group, the pink group, what is the GCF of the 2 terms in the pink parentheses? What could both of these terms be divided by? X. No number could come out of 5 and 2, but an X can come out of both of those terms. Remember, you don't have to actually show the dividing by X, but for some people that's helpful. So if I divide out that X in this first term, I'll be left with 5y. And in that second term, I'll be left with plus 2. Now in this second set, what can both of these be divided by? My second group. 25y and 10 have what GCF? 5. Now, the lead term is negative. The first term is negative. We always factor out that negative. So I'm not just going to factor out 5. I'm going to factor out negative 5. So if I do that division, negative 25 divided by negative 5 is positive 5. And then that y is still there. A negative divided by negative is going to become a positive, and 10 divided by 5 is 2. All right, are we on the right track? Are our leftovers the same? They are, so that means that that's a good sign, and that 5y plus 2 is a factor. And then what's the second factor going to be? It's bringing, that GCF of each of those together, so x minus 5. So we bring the x minus 5 together, and we have that binomial that was the same. Easy peasy, right? All right, let's try B. Starts with 9x minus 2y squared minus 18y plus xy. Is there a GCF here? No. Now, if I try to start by grouping these the way that they're listed, I can see right away these first two terms, they have no GCF, do they? No. Okay. And these second two terms do, they have a y in common, but I know I'd still be left with an 18 plus x or 18 minus x if I factor out the negative. And that's not going to match, is it? It's not going to match that first group where I have nothing to take out. Do y'all agree? I think my computer is moving, but my screen up there for y'all is frozen. Let me see if I can unfreeze it. Anyway, so I could rearrange these terms to try and pair. Okay, let me try and reconnect to that. Okay, there we go. That's better. All right, so what I was saying is I'm going to try to rearrange these terms because the way that they're arranged right now, grouping's not going to help me. So I'm going to, instead of starting with my 9x, I'm going to start with, well, actually I can start with 9x, that's fine. But I'm going to move this last term that has an x in it up next to it so that the x term, okay, and then I'll have the negative 2y squared and the minus 18y. So now if I do my grouping, I've got a GCF that I can take out of each of these. In the first group, I've got the x. I can take out x from both terms. So that would be a GCF of x, and my leftovers would be 9 plus y. And then in the second group, I have a negative lead term And so I'm going to take that out. Oh my gosh. I don't care. Okay, that's just going to stay there. That's annoying. I can take out a 2y, so a negative 2y. So if I take out negative 2y, what am I going to be left with in each term? So here, the negative 2's would reduce, y squared over y would just be left with y. And then over here, the negatives divided would become a plus, and then 18 divided by 2 is 9, and the y's reduce. Now do my leftovers match? Oh, it's not showing up on the screen what I'm doing. It's fantastic. Of course, all of this is going to happen when I'm trying to record. Let me try disconnecting and reconnecting to that projector for y'all. Bless you. Okay, so now y'all can see what I wrote. All right, so are my leftovers the same now? 9 plus y and y plus 9. They don't look identical, but does it matter if they're both positive numbers? Does it matter which order I add in? No. So these are the same. Our leftovers are the same. Okay, so it's okay that they're in a different order since they're both positive, since we're adding them. So y plus 9 or 9 plus y, I prefer to write my variable first, and then I bring together the GCFs that I took out. And those are my two factors. So far, so good? All right. Let's try C. In C, is there a GCF that I can pull out? There's not. So I'm going to try grouping. Now, you may ask, how do I know if I need to rearrange or something? This is already in standard form. So you see x cubed, x squared, x, and then your constant, right? So it's good to go. This one that we ended up rearranging was all mismatched, okay? Your x's weren't together. So that's why we needed to rearrange that one to make that one work. Okay, this one does not need to be rearranged. We're ready to do our grouping. Let's see, both of these I could divide out a 5 and an x squared. So if I take out 5x squared, I would have leftover of x plus 2. And then here, there is no GCF. It would be just an understood 1. And so I would still have 2x plus 5. Are my leftovers the same? They're not. So then the question is, did I make a mistake in taking out my GCFs? Or possibly does it need to be rearranged? Okay, so a few questions that you may go through in your head. But remember, if you've done your factoring correctly and those don't match, what does that mean? It's prime. It's not factorable. Okay, so this is the case here. You're welcome to try rearranging these terms different ways and trying different groups, but I'll let you know right now, to save you the time, none of them work. Okay, so this one is prime. Could not factor that one. All right, what about here in D? Is there a GCF I can take out first? Yeah, it has to be able to factor out of all the terms to be a GCF. Yeah, 3. All of those terms can be divided by 3. So I take out a GCF of 3. And what's that going to leave me with? Yeah, x cubed plus x squared plus x plus 1. So now I've got 4 terms, standard form. I'm going to try to group. And now, the 3 that we factored out does not go anywhere. So I'm going to leave it out there out front. Now I'm going to do my grouping. In pink, what can I factor out of x cubed and x squared? X squared. And that would leave me with x plus 1. And then in green, my second group, there's nothing to factor out. It would be an understood 1, and I'm left with the x plus 1 still. So when I look at that, are my leftovers the same? They are. That's a good sign. So x plus 1 is a factor. And then my other factor comes from bringing those GCFs together. So x squared plus 1. And then I don't forget, and actually I don't need that bracket anymore. That 3 did not go away. That 3 is still out there in front. All right. How you feeling? Feel okay about grouping? All right, then let's flip over. That's the last type of factoring. So far we've covered GCF, greatest common factor. We've done quadratic form trinomials with guess and check, box method, and grouping. We have done special cases, and we've done that when A is equal to 1 and when A is greater than 1. Then we did special cases with difference of squares, difference of cubes, sum of cubes, and perfect square trinomials. And now we've done grouping when you have 4 terms, not just trinomial grouping. So now we're going to look at some examples that look a little more complex because these may have multiple steps, like multiple types of factoring that have to be done in one problem. So when we look at this first one, the first thing I always look for in all of my problems is a GCF. So is there a GCF? There are 4 terms here. 1, 2, 3, and 4. Is there a GCF that can be pulled out of all 4 of those? Do they have anything in common that they could all be divided by? No, they don't. Okay, so it's 4 terms. That should be a hint to what type of factoring I should do. What is it? There's 4 terms in this expression. We literally just did it on the front. We tried GCF first. There is no GCF. What? Grouping. We're going to do grouping. We've got 4 terms. There's no GCF. I'm going to try grouping. So I'm going to create my 2 groups. All right, so the first group in the pink parentheses, what could I divide out of both of those terms? What do they both have in common? C squared, x squared. Now, if I divide that out, and again, you can show it if you need to, the c squared's reduced, the x squared's reduced, I'm left with just the b squared. Same thing over here. If I do c squared and x squared, they'll both reduce and there's nothing left. It's an understood what? Anything divided by itself is 1. It is not a 0. There is still something there. It's a 1. Okay, now in green, The lead term is negative, so I know for sure I'm factoring out a negative. Okay, and then what do they both have in common that I can factor out? 4a squared. They both have a coefficient of 4 and they both have an a squared. So the 4's would reduce, the a squareds would reduce. I'd be left with b squared there. Oh, I didn't write the 4a squared. Sorry. Let me fix that. Factoring out the negative for sure, and then 4a squared. So that leaves me with b squared. And then if I'm dividing out a negative, that's going to become a minus. And then the 4's reduce, the a squareds reduce. It's an understood 1 again. So are my leftovers the same here? They are. That's a good sign. So the grouping worked. I was able to factor by grouping. So I'm going to create two binomials. I have the b squared minus 1. And then I've got the c squared x squared minus 4a squared. I brought those GCFs together, and then I had those. Now, on the front, when I did this, I was done. But look at these two binomials that you're left with. See how there's still a lot of squared terms, aren't there? What did we practice yesterday? We were dealing with squared terms. If you look at this binomial, this is a difference, it's subtraction. And are both of these perfect squares? Could I take the square root of both of these? I can. The square root of 1 is just 1. The square root of b squared would be b, wouldn't it? These are both perfect squares, and it's the difference. So this goes back to what we learned yesterday, difference of two squares. So I could factor this binomial further. This is partially factored, but it's not completely factored. So I could take this further and say, okay, the difference of squares says that when I have this, I take the square root of the first term, that would just be b, and the square root of the second term, that would just be 1. And what do I put in between? What's the difference here in these two binomials? Do y'all remember? You can get your notes out from yesterday if you need to look at them. This is a difference of squares. You get one positive and one negative. So that factored a step further, b plus 1 and b minus 1. Now what about this next binomial? I know it looks more confusing, but aren't all the variables there squared? And the number that's there a perfect square also? And it's subtraction. So this is also a difference of squares. So we could actually take this one a step further and use difference of squares as well, where we're going to have 1 plus and 1 minus. We're going to take the square root of the first term. So what would the square root of cx or c squared x squared be? Just cx. And what would the square root of 4a squared be? Not 4. What's the square root of 4? 2. So 2a. Now, none of those can be factored any further because none of those are squares or cubes or anything like that. There's no powers left on any of those variables. So that's as far as I can take it. So I did grouping. And then I did difference of squares. So this is what I mean when I say multi-step. There were two different types of factoring that I had to do to completely factor that expression. All right, what about number 2? So number 2, it is a trinomial. So I could ask myself if it's a perfect square trinomial. Is 8 a perfect square? No. So I know it's not a perfect square trinomial right away. 8 is not a perfect square. Okay, so I may have to just do my trinomial factoring where I do the X method, or I do the guess and check, the box method, the grouping, any of those 3 methods that you prefer. The difference that you see here is y'all were used to seeing most of the examples that we did just had x squared and then x and then a constant, right? This one is x to the 6th, x cubed, and then a constant. So you need to understand that the same process we used when it's x squared and x and a constant, if it's in this same trinomial format, as long as this exponent at the front is double this exponent in the middle, it's going to work out. So we're going to be able to do the same thing. It's just instead of just x, it's going to be x cubed. So do y'all want to do guess and check, grouping, or box method? Grouping? Okay, so I'm going to start with my x method. I'm going to say, so that's an understood 1 times -8. So what multiplies to -8, but adds to -7? -8, +1. Good. So if I'm doing grouping, then I am replacing that middle term with the I just came up with. So x to the 6th is going to stay as is, but instead of -7x cubed, I'm going to have -8x cubed plus 1x cubed. So I make that substitution, and then I still have -8 at the end. So then I do my parentheses for grouping. In my first group, what could I factor out of both of those? X cubed. And that would leave me with x cubed -8. And in my second group, there is no GCF. It would be an understood 1. And so I would be left with the x cubed -8. And what do you know? The leftovers are the same. That's a good sign. So x cubed -8 is a factor. And then I can bring together the GCFs that I took out, x cubed +1. So I have factored that trinomial into 2 binomials by factoring by grouping. Okay, this was a trinomial factor by grouping. But the thing is, I'm not done. That is not completely factored, because if you look at these binomials, all of these terms in both of these are perfect cubes. The variables are cubed, and 8 and 1 are both perfect cubes, right? So I can actually take both of these a step further. This one is the difference of cubes. And this one is the sum of cubes. So I'm going to have to expand both of these a little bit further. So remember, I identify my A and B. So the cube root of x cubed is x. and the cube root of 8 is 2, right? So the difference of cubes, and you can look at your notes for the formula. You don't have to have the formulas memorized. I told y'all are going to get the formulas on the test, but the formula for difference of cubes says that we do a minus b, so that's x minus 2. And then a trinomial, it's a squared, so this is x squared, plus a times b, so 2 times x, plus, and then b squared. Well, what is 2 squared? What is 2 squared? 4. So that's the difference of cubes factoring of that. We took it a little bit further. Now, the sum of cubes for this binomial, my a would be x, and the cube root of 1 is 1. So my b would be 1. Now for the sum, I would do a plus b, so x plus 1. And then it is a squared, so x squared, minus, and then it's a times b, so x times 1 is just x, plus, and then b squared. 1 squared is just 1. So now those are, that is completely factored. We had to factor by grouping, and then the 2 binomials we ended up with factored even further. Then you have these trinomials. You could check the trinomials and see if they're factorable any further. So for instance, this one, the a is an understood 1, so it's something pretty quick we can ask ourselves. Are there any factors of 4 that would add to 2? So 4 and 1 or 2 and 2? Would either of those add to 2? No. Okay. Are there any factors of 1 that would add to -1? And the answer is no. But anytime you end up with a trinomial, you can always ask yourself that. You can check to see, oh, can I factor that any further? In this case, you cannot. So these multi-step factoring ones, I'm going to tell you right now because I don't want you to freak out about these. These are definitely harder. These are not going to be on the test. These are a really good way to practice to see if you have a good understanding of the different factoring steps, the different factoring methods, if you can combine them and use them in more than one in a problem. Okay, so it's good practice. I'm not going to ask you to be able to do that on the test though. Okay, maybe a bonus question, but not one that would hurt your test grade. Okay. Let's see, how much time do we have? We can probably do one more of these. Let's look at, I guess we'll just do 3. Do I have a GCF here? So always, always, always look for a GCF first. So is there anything that can be divided out of all 3 of those terms? Sorry, say that again. Yeah, they all have A. They all have A. The first term, it's just a single A. There's no power, so that's all we can take out. So I can take out an A, and that would leave me with 6x squared. If I take out an A here, that would just be AX. And if I take out an A there, that would be A squared. Okay. So now this is set up as I took out my GCF. So now what's left is a quadratic form trinomial. So I could do my guess and check, or I could do that X method and then grouping or box method. Does anybody have a preference on one of those three methods? Six and 20 are not prime, so I probably won't do guess and check. So I will do our X. Okay, so our C, A times C. So what is 6 times negative 20? And it's technically negative 20a squared, so we can include the a's there if that helps you. So that's going to be negative 120 a squared. I probably should have written my x bigger. I'll fix that real fast. There we go. And then my b term is 7a. So then I'm asking myself for factors of negative 120 that add to 7. So 120 obviously could be 120 and 1. It could be 60 and 2, 40 and 3, 30 and 4. Those are all going to be too far apart to leave us with 7. If I keep listing through my factors, I get to 15 and 8. Okay. And if I want it to come out to a positive when I add, but a negative when I multiply, no, one's going to have to be positive, one's going to have to be negative. I could do a positive 15 and a negative, sorry, not 7, negative 8. Now, the fact that that has A's in it, we have to have an A in both of these. So 15 times negative 8 would give me negative 120, and 15 plus negative 8, or 15 minus 8, would give me the 7. So now I can do my substitution. That A in front didn't go anywhere. First term stays as is. Now I'm replacing 7ax with 15ax and minus 8ax. And the last term doesn't change. So again, this is the substitution I made right here. Now I can do grouping. Or if you prefer box method at this point, you could do box method. So in the first group, I could factor out a 3x. And that would leave me with 2x plus 5a. And in the second group, definitely factor out the negative, and then I could factor out a 4a. And that would leave me with 2x. And the negative divided by the negative is going to make it out a plus. And 20 divided by 4 is 5. And I factored out an a, so I'm left with an a. And how about that? My leftovers are the same. That's a good sign. So I had all of that from the grouping, and I still have that a in front. So the a in front is still there. And then my new groups are the 3x minus 4a. And then from the one that came out the same, that's 2x plus 5a. Neither of those are squares or cubes or anything like that. That's as far as I can take it. So in that one, I did GCF first. And then I did trinomial grouping. You could have done box method or guess and check there once you got to the trinomial as well. I'm going to show you one more time. In Desmos, if you're like, how did you get those factors? Remember, you can use Desmos the entire test. So if you need help finding factors, you can make a table. and make the y of your table just what you want to know the factors of. I wanted to know the factors of negative 120 and put it over that x1. And then start typing in. See, I'm seeing all these possible factors, not decimals. Decimals don't count. And there it is, 8 and 15. And we just had to figure out the signs. Does that make sense? Remember, you can find factors using Desmos if you don't know them or have trouble finding factors in your head. All right, I'm gonna let y'all go ahead and get packed up because we're gonna be out of here soon. I am gonna go ahead and do this last example on the recording while y'all are packing up. But again, these on the back, they are designed to be more challenging. This may appear as like a bonus question on the test, but I won't be expecting you to do questions like this on the test unless it was an extra credit or a bonus. Okay, it's just really good. It reiterates, if you're able to do this caliber question, you've got like an excellent understanding of those factoring methods if you can combine them. Okay, so study those notes. We'll, I was planning to quiz tomorrow, but since we didn't have time to really get to the practice today, I'll give y'all some time to practice those special cases tomorrow. And I'll push the quiz to Friday. I'll still hand out the review tomorrow for those who finish the practice or want to start the review early. But we'll quiz on Friday. And if you have class time after you quiz, then you can work on your review. And then Monday will be a review day, and then your test will be Tuesday. All right. So for this one, I'm going to look for a GCF first. It's always my first step. And I can see I do have a GCF here. These are definitely all divisible by 5 at least. Y'all have a good day. And I think that's divisible by more. Let's see. 45 is divisible by 9. Let's see. 120. Would not be divisible by 9. So about 15. So 45 can divide by 15. 120 can divide by 15. 80 cannot. Okay, so we'll just stick with the 5 then. So 45 divided by 5 is going to be 9x squared. 120 divided by 5 is 24. So that's xy. Sorry, I'm recording, but you can tell me something real fast. Okay. All right. Thanks. Would you mind closing that door for me? Thanks. All right. And then we take the GCF out of that last one. We get 16 y squared. So if you're ever unsure of your GCF, like we just take out the 5 and you're like, I'm not sure if that's the greatest one. Look at what's left and see. Can all of these still be divided by something? So 9, the only thing it can be divided by is 3. 24 can be divided by 3, but 16 can't. So 5 was our GCF. If you took out something too small and everything was still divisible by something, you just then divide it out again. And you would end up with 2 numbers out here you would multiply together. And that would have been your GCF to begin with. Anywho, so now we've got it down to a trinomial. Now, this trinomial, remember, we can ask ourselves, is it a perfect square trinomial? That was a special case that we talked about yesterday. Or you can just go straight into what we did up here and do like your X method and factor by grouping, or box method, or guess and check. But if it's a perfect square trinomial, there's a shortcut because it's a special case. So remember, if you're asking yourself, is it a perfect square trinomial? The first term needs to be a perfect square, which this one is. So that is the square root of 9x squared would be 3x. And the last term needs to be a perfect square, which it is. The square root would be 4y. Then the middle term would have to be 2ab. Okay, so double that a times b. So 3x times 4y would be 12xy, and then we double it, and it's 24xy. So this indeed is a perfect square trinomial once I took that GCF out. So my perfect square trinomial shortcut says I can just do a plus or minus b squared. Now the plus or minus comes from here. So this one's minus. So it is 3x minus 4y squared. Now the GCF that we took out at the beginning, let me get a different color, did not go anywhere. It is still there. So don't forget that that is still there. Don't leave it off. So we did GCF. And then this was a perfect square trinomial. All right. So 4 kind of complex ones. Again, those would just show up as bonus type questions where you're compounding different types of grouping together within one problem. The front side for sure, though, would be on the test. You do need to be able to do your grouping when you have those 4 terms. Okay, and don't forget, take out a GCF first if you need to, then do your factor by grouping and have your final answer. Now, if any of those binomials that you end up with could be factored further, you would need to take it a step further. Okay, that's it. We'll do some practice tomorrow and then take that quiz on Friday.